Welcome to our comprehensive guide on deploying and integrating data science solutions using APIs. In today's fast-paced digital world, organizations need to quickly turn their data science models into actionable tools. APIs, or application programming interfaces, play a crucial role in bridging the gap between complex models and real-world applications. Throughout this video, we'll explore the step-by-step process of deploying data science models as APIs and how to seamlessly integrate them into various business systems. Whether you're a data scientist, developer, or business leader, understanding this workflow is essential for maximizing the impact of your data-driven insights. APIs have become the backbone of modern software development, especially in data science. They allow different systems to communicate efficiently, making it possible to deploy machine learning models and access their predictions from anywhere. By exposing your data science models through APIs, you enable other applications, websites, or even mobile devices to leverage your insights in real time. This not only increases the reach of your solutions, but also ensures scalability and flexibility. In this scene, we'll discuss the core reasons why APIs are the preferred method for deploying data science solutions. Before diving into deployment, let's clarify what an API is. An API, or application programming interface, is a set of rules that allows different software components to communicate. In data science, APIs are used to send data to a model and receive predictions or results. Think of it as a messenger that takes your request, delivers it to the model, and brings back the answer. Understanding this basic concept is vital for anyone looking to deploy or integrate data science solutions effectively. First step in deploying a data science solution is preparing your model. This involves ensuring your model is trained, validated, and ready for production. You'll need to save the model in a format that can be loaded by your API service, such as a pickle file for Python models. It's also important to document the model's input and output requirements, so that integration with the API is smooth and error-free. Proper preparation sets the foundation for a successful deployment. Selecting the right framework for your API is crucial. Popular choices include Flask, FastAPI, and Django for Python-based models. Each framework has its strengths. Flask is lightweight and easy to use. FastAPI offers high performance and automatic documentation, while Django provides robust features for larger applications. Your choice will depend on your project's requirements, team expertise, and scalability needs. Let's look at the pros and cons of each to help you decide. So you've chosen your framework, it's time to set up your development environment. This typically involves creating a virtual environment, installing necessary libraries, and configuring your project structure. Using tools like pip or conda, you can manage dependencies efficiently. Setting up a clean environment ensures that your API runs smoothly and avoids conflicts between different packages. This step is essential for both development and future maintenance. Now let's build the API endpoint that will serve your data science model. An endpoint is a specific URL where users can send requests to get predictions. You'll define routes in your chosen framework, specifying how data should be received and how the model should process it. This is where you connect your trained model to the outside world, making it accessible to other applications. Careful design of endpoints ensures security and usability. Handling input data correctly is vital for your API's reliability. You need to validate incoming requests, check data types, and handle missing or malformed data gracefully. Many frameworks offer built-in validation tools, but you may also need to write custom checks. By ensuring that only valid data reaches your model, you protect against errors and improve the overall user experience. Let's explore best practices for input validation. Once your API receives valid input, it processes the data through your model and returns predictions. The response should be clear, concise, and in a format that's easy for other systems to consume, such as JSON. It's important to include relevant information like prediction confidence or error messages to help users interpret the results. Consistent and well-structured responses make integration with other applications much easier. Thorough testing is essential before deploying your API to production. You should test with a variety of input scenarios, including edge cases and invalid data, to ensure your API handles everything gracefully. Automated testing tools can help you run these checks efficiently. Testing not only catches bugs but also ensures your API meets performance and reliability standards. This step is critical for building trust with users and stakeholders. Clear and comprehensive documentation is a cornerstone of successful API deployment. Your documentation should explain how to use the API, what inputs are required, and what outputs to expect. Tools like Swagger or OpenAPI can help you generate interactive documentation automatically. Good documentation reduces confusion, speeds up integration, and helps users get the most out of your data science solution. Security is paramount when deploying APIs, especially for data science solutions that may handle sensitive information. Implement authentication and authorization mechanisms to control who can access your API. Use HTTPS to encrypt data in transit and consider rate limiting to prevent abuse. Regularly update your dependencies and monitor for vulnerabilities. By prioritizing security, you protect your data, users, and reputation. Cloud platforms like AWS, Azure, and Google Cloud make it easy to deploy your API at scale. These platforms offer managed services for hosting, scaling, and monitoring your API. You can choose between serverless options like AWS Lambda or container-based deployments using Docker and Kubernetes. Cloud deployment ensures high availability and allows your data science solution to serve users around the globe. After deployment, continuous monitoring and logging are essential for maintaining a healthy API. Monitoring tools can track usage, performance, and errors in real time, while logs provide detailed records for troubleshooting. Set up alerts for unusual activity or performance drops. Regular monitoring helps you catch issues early, optimize performance, and ensure your data science solution remains reliable over time. As your data science solution gains users, you may need to scale your API to handle increased demand. Cloud platforms offer auto-scaling features that automatically adjust resources based on traffic. You can also use load balancers to distribute requests evenly across multiple instances. Proper scaling ensures your API remains responsive and reliable, even during peak usage. Over time, your data science models and APIs will evolve. Implementing versioning allows you to introduce new features or improvements without breaking existing integrations. Common practices include adding version numbers to your API URLs or using headers to specify versions. Versioning helps you manage updates smoothly and ensures backward compatibility for your users. One of the main advantages of deploying data science models as APIs is the ease of integration with web applications. Front-end developers can call your API to fetch predictions and display results to users in real time. This enables interactive dashboards, personalized recommendations, and more. In this scene, we'll explore how APIs connect data science models to web interfaces, enhancing user experiences. APIs also make it possible to bring data science solutions to mobile devices. By integrating your API with mobile apps, you can deliver intelligent features like image recognition, language translation, or personalized notifications directly to users' phones. Mobile integration expands the reach of your models and opens up new opportunities for innovation. Many organizations use APIs to integrate data science models with existing business systems, such as CRM, ERP, or marketing platforms. This allows for automated decision-making, improved workflows, and enhanced analytics. By connecting your API to these systems, you enable seamless data flow and unlock the full potential of your data science solutions. APIs can be designed for batch processing or real-time predictions. Batch APIs handle large volumes of data at once, making them ideal for periodic analysis or reporting. Real-time APIs, on the other hand, provide instant predictions for individual requests. Choosing the right approach depends on your use case and performance requirements. Let's compare the benefits and challenges of each. Robust error handling is essential for a reliable API. Your API should return clear error messages and appropriate status codes when something goes wrong. This helps users understand what happened and how to fix it. Implementing structured error responses and logging errors for later analysis are best practices that improve the overall quality of your data science solution. API keys are a common method for controlling access to your API. By issuing unique keys to each user or application, you can track usage, enforce limits, and revoke access if necessary. Managing API keys securely is important for protecting your data science solution from unauthorized use. Let's discuss best practices for generating, storing, and validating API keys. Prevent abuse and ensure fair usage. Implement rate limiting and throttling in your API. This means restricting the number of requests a user can make within a certain time frame. Rate limiting protects your resources and maintains performance for all users. Most frameworks and cloud platforms offer built-in support for these features, making them easy to implement. Logging user activity helps you understand how your API is being used and identify potential issues. By recording requests, responses, and errors, you can analyze usage patterns, detect anomalies, and improve your data science solution over time. Make sure to handle sensitive data responsibly and comply with privacy regulations when logging user activity. Adopting continuous integration and deployment (CI/CD) practices streamlines the process of updating your API. Automated pipelines can build, test, and deploy new versions quickly and reliably. This reduces downtime, minimizes errors, and allows you to deliver improvements to users faster. CI/CD is a key component of modern API development workflows. Automated testing tools like Postman, Pytest, or Unitest help ensure your API works as expected. These tools allow you to create test cases for different scenarios and run them automatically during development and deployment. Automated testing catches bugs early and ensures your data science solution remains robust as it evolves. API Gateway acts as a single entry point for all your API requests. It can handle routing, authentication, rate limiting, and more. Using an API gateway simplifies management and enhances security for your data science solutions. Popular options include AWS API Gateway, Kong, and Apigee. Let's see how an API gateway fits into your deployment architecture. Containerization using Docker allows you to package your API and all its dependencies into a single, portable unit. This makes deployment consistent across different environments and simplifies scaling. Docker containers can be deployed on cloud platforms, on-premises servers, or even your local machine. Containerization is a best practice for modern API deployment. Kubernetes is a powerful tool for orchestrating containerized applications. It automates deployment, scaling, and management of your API containers. With Kubernetes, you can ensure high availability, roll out updates smoothly, and recover quickly from failures. This makes it ideal for large-scale data science solutions that require robust infrastructure. Serverless platforms like AWS Lambda, Azure Functions, or Google Cloud Functions allow you to deploy APIs without managing servers. You only pay for the compute time you use, and the platform handles scaling automatically. Serverless deployment is cost-effective and ideal for APIs with variable or unpredictable traffic. High availability means your API is accessible whenever users need it. Achieve this by deploying across multiple servers or regions, using load balancers, and setting up failover mechanisms. Cloud providers offer tools to help you design for high availability, ensuring your data science solution remains reliable even during outages. Performance optimization ensures your API responds quickly and efficiently. Techniques include caching frequent responses, optimizing model inference time, and minimizing data transfer. Monitoring tools can help you identify bottlenecks and areas for improvement. Fast, responsive APIs enhance user satisfaction and support demanding applications. Sometimes, your API may need to handle large data payloads such as images or bulk records. Use techniques like data compression, chunked uploads, or asynchronous processing to manage these efficiently. Proper handling of large payloads ensures your API remains responsive and reliable, even with demanding workloads. API analytics provide valuable insights into how your data science solution is being used. Track metrics like request volume, response times, and user demographics to understand usage patterns. Analytics help you make informed decisions about scaling, feature development, and user support. Your API may need to serve multiple data science models, each with different purposes. Design your API to handle model selection, versioning, and routing requests to the appropriate model. This flexibility allows you to support a wide range of use cases and adapt to changing business needs. A/B testing allows you to compare different versions of your data science models or API endpoints. By randomly assigning users to different versions, you can measure performance and user satisfaction. A/B testing helps you make data-driven decisions about which models or features to deploy widely. Collecting feedback from API users is vital for continuous improvement. Provide mechanisms for users to report issues, suggest features, or share their experiences. Use this feedback to refine your data science models and API functionality, ensuring your solution evolves to meet user needs. In deploying data science APIs, compliance with privacy regulations like GDPR or HIPAA is essential. Ensure you handle personal data responsibly, obtain necessary consents, and provide mechanisms for data deletion or access requests. Compliance builds trust with users and protects your organization from legal risks. Managing costs is an important aspect of API deployment, especially in the cloud. Monitor resource usage, optimize infrastructure, and choose cost-effective deployment options. Implementing auto-scaling and serverless solutions can help you control expenses while maintaining performance. Prepare for unexpected events by developing a disaster recovery plan for your API. Regularly backup your models and data and set up automated failover systems. Test your recovery procedures to ensure you can restore service quickly in case of outages or data loss. OpenAPI and Swagger are popular tools for designing, documenting, and testing APIs. They allow you to define your API structure in a standardized format and generate interactive documentation. Using these tools streamlines development and makes it easier for others to integrate with your data science solution. Publishing your API on marketplaces like RapidAPI or AWS Marketplace can expand your reach and attract new users. These platforms handle billing, access control, and discovery, making it easier to monetize your data science solutions. Marketplace integration is a great way to scale your impact. Let's look at a real-world example of deploying a data science solution with an API. A retail company wanted to predict customer churn using a machine learning model. By deploying the model as an API, they integrated it with their CRM system, enabling real-time risk scoring and targeted retention campaigns. This approach improved customer retention and demonstrated the power of API-driven integration. Deploying data science APIs comes with challenges. Common pitfalls include poor documentation, inadequate security, and lack of monitoring. Avoid these by following best practices, document thoroughly, secure your endpoints, and set up robust monitoring. Learning from others' mistakes can save you time and resources. This video, we've covered the end-to-end process of deploying and integrating data science solutions with APIs. From preparing your model and building secure endpoints to scaling, monitoring, and integrating with business systems, each step is crucial for success. As you move forward, apply these best practices to your own projects and unlock the full potential of your data science investment.